Okie dokie, let's do this. Hello, everybody. Can you see me? Can you hear me? How is the transmission? As I always like to start. Am I audible? Awesome, I'm visible. Welcome to another Meyer Sound webinar. Today we're going to talk all about IntelligentDC. And as you've grown accustomed, I'm going to give you some Zoom instructions first to make an effort in channeling Q&A. So without further ado, let me share my screen and let's look at some household notes. Today we will be joined by technical support specialist Rahul Samuel, who's going to talk about IntelligentDC. I'm going to give the microphone and the screen to Rahul in a while. But first, let's do some housekeeping. So we're using the video communication platform called Zoom, and in front of you, you're expected to have a window not unlike the one that you see over here. If you want to see who else is joining you in today's session, just click on Participants, in which case a window opens up to the right-hand side where you can see your fellow attendees. And if you would like to ask questions, I'm here to moderate today's webinar, so I will be monitoring the chat. If you would like to ask questions, please click on the chat balloon, in which case the right pane splits in half and a chat box opens up, and at the bottom of that chat box you can address either the nation by sending a message to everyone, or if you happen to see a family member, friend, or fellow colleague, you can also send a message to that person in private. That concludes the household notes. For those that are joining us through the Facebook group called Meyer Sound User Community, welcome. We're streaming live as we speak, so welcome to those people as well. For those that are not familiar with the Facebook group, it's a dedicated Meyer Sound User Community, which counts currently over 8,500 members, and we would be delighted if you join that group. I will come back to you at the end of today's webinar with some more household notes about where to find these recordings and such. But as far as introductions are concerned, I'm proud to introduce to you fellow Meyer Sound colleague, Rahul Samuel, technical support specialist at Meyer Sound. Rahul, are you there? Are you with us?
Yes, I'm here. This is me. Thank you, Merlin. Thank you for introducing and doing the housekeeping. I appreciate it. Is my audio loud and clear? Again, I would like to check like you did.
Loud and clear, sir. I can hear you.
Perfect. Thank you. Thank you. So first of all, thank you all for taking the time to join us again today for another webinar. I will quickly start sharing my screen. And there we go. So yep, perfect. So as Merlin said, today's topic of discussion is IntelligentDC. This is, today we will talk about spaces not different from the one you see on your screen right now. We're looking at distributed audio. We will look at how to approach such a distributed system design. I will try and show you a quick checklist and how the workflow for a design like this would be. We will also look at taking advantage of RM server to monitor such a distributed system. These are the goals. And to start off, we will break down today's session. We will look at a little bit of history. We will look at some of the advantages of a self-powered system. We will go into detail and look at IntelligentDC, which would include a system overview. We will look at the products that are included as part in this family. We will look at 4 projects that we've handpicked as case studies to see how these products can be placed into different kinds of applications. And as I promised in the beginning, we will take a quick look at how to approach a design for a system like this. So to start off today's session, back in the day, companies built loudspeakers, but it was all up to the owners to decide how to drive them, what kind of amplification they chose. It would depend on EQs, filters, And the result of this was inconsistent performance. So even though you have the same loudspeaker in two different places, they could sound completely different from each other. And this bothered John Meyer. Back in the 70s, while he was working in McCune Sound, he started focusing on not just building quality products, but also implementing consistency in these products. And what you see in the picture here is the JM10 system, which is a system that was comprised of the loudspeakers, as you see, and also a dedicated rack that was that carried all the processing and amplification that you would require to drive a system like this. And he continued his quest at Myerstown. And in 1989, he came up with the HD1, which is what you see on your screen right now. It would be the first self-powered loudspeaker with everything built inside the speaker enclosure. And what you see under that, under the picture, is two traces, the top trace being that of the frequency response of that loudspeaker, and the second trace showing you the phase. As you would see, that is very impressive. So John Meyer's philosophy of no compromise to the integrity of any system continues. And the key benefits of using self-powered systems is one, the main one I think, according to me, is that it's plug and play out of the box. So you take a loudspeaker out of the box, no matter where in the world you are, you power it on, you put signal, you send signal out to it, and it'll sound exactly the way it was designed to sound at the factory, which is great because you get consistent performance no matter where you power the loudspeaker, no matter where you place it, it's going to sound exactly the same. And because of perfectly mated amplifier and processing, these loudspeakers are extremely power efficient, not just in terms of what they consume, but in terms of how they reproduce sound. You also get reliable protection because of this perfect mating, because you have a given amplifier that is designed to drive a given transducer. And for consultants and integrators and people who are designing these systems and integrating the system, your designs will stay true because you have taken so many factors out of the picture that could change a design. So whatever you design, whatever you conceive and imagine your system to be, that is exactly how it's going to sound when it comes out, because you have no presets to play with, you have no variation in amplification and all those factors. We're also minimizing failure points by doing this, because now your amplifier, your DSP, and your loudspeaker all live in one package. And you're reducing human error of loading wrong presets or connecting the wrong wire to the wrong amp and those kind of things. And when you look at the overall picture, you're also reducing cost of ownership. And we will take a look at that as we go through the session today. Intelligent DC. So it's not something new. It's been around for a long time. It's been evolving over the years. In the late 90s, in the late 90s, the HM1 was brought out, which is what you see on your screen right now. This is the first loudspeaker with an external or remote power supply. This was done to come up with a smaller footprint loudspeaker, and there was another version of this, the 1S, which was used, which was for studio referencing. Then the MM4, no, that's not a typo. I did not forget to put the XP there. There used to be a version called MM4, which doesn't look very different from the MM4 that we all know and love today. But if we take a look at the back, you will see that it is not the same. It is actually a passive loudspeaker and very different from what we have today. This was driven by the MM4 CEU, which is the control unit that was used to process the signal that reached the loudspeaker. And to see an overview of how a system, an MM4 system would look, it would have an MM4 CEU, which is driving all the amplifiers. There was some smart electronics controlling what was coming out of the amplifier, and the signal will reach the MM4s. But then again, we were back to square one, and John Meyer was unhappy with how inconsistent the performance of the MM4 was, because there were so many variables that couldn't be controlled and that could compromise the system knowing or unknowingly. And thus came about IntelligentDC. So before we get into the what, how, and why, let's look at the alternative, which is constant voltage system or high voltage auto distribution system. A lot of us know them as the 70 volt system or the 100 volt system, depending on where you are. These systems rely on the same transmission technology that power grids use to transfer send electricity to your homes. So at the grid, you have a step-up transformer, which brings the voltage of these, which brings the voltage up, and thus bringing the current down. And then at the destination, you have a step-down transformer, which would bring the voltage down and current up again. Now, these systems, we know they run multiple speakers on a line. And as we will see, these transformers that are used to transmit electricity or power, stepping up and stepping down, start becoming inhibitors for audio. Now, some of the shortcomings of a constant voltage system. One is poor frequency response. This happens because of the way it's being signal is being transmitted through transformers, which, as we know, can start acting as capacitors and thus end up in combination with the cable and other factors start filtering out frequencies. We're all familiar with this. We've heard constant voltage systems, and they have a very narrow bandwidth. You start losing a lot of low end and high end. Distortion is another factor. This is also something most of us would have heard. This happens because it's hard to really predict when this distortion is going to happen, because this distortion comes from transformer saturation, which is hard to predict. But the effects of that transformer saturation on audio is quite detrimental. Insertion loss, this is again something people who have dealt with constant voltage systems will know. You know the rule of thumb, you always specify 1.5 times the amplification power than what you actually need, because you're expecting those kind of losses. Inconsistent, the same loudspeaker with the same amplifier could sound different depending on how many loudspeakers you have on a line, which is how much load you have on a line, and it could also change depending on how far each loudspeaker is from that amplifier. A single amp drives multiple speakers. This is a great thing, but if you were to lose one amp from a failure, you're going to lose a lot of loudspeakers. This could wipe out a complete zone. It could wipe out a complete area, which is not a great thing. And because of the way audio is transmitted through one amplifier into multiple loudspeakers, time aligning such a system is impossible. And as we go through the case studies, you will see how time aligning and all these factors are becoming more and more relevant, and how important it is to consider these things. So what is intelligent DC? In simple words, it is a self-powered loudspeaker system with an external or remote power supply. The driver, amplifier, DSP are built inside the loudspeaker, and you have a standard 48-volt power supply that will power up all of the intelligent DC family of loudspeakers. So how do you identify this? If the loudspeaker model ends with an XP, that is an intelligent DC product and can be powered using any of our MPS power supplies. So why intelligent then? What's so intelligent about it? Well, the MPS does it doesn't just power up the loudspeakers, but we are also able to do signal distribution, and we're able to remotely monitor every output of the MPS with an optional RMS card, which we'll look at in a bit. So why did we create this? Obviously, we wanted to keep all the advantages of a self-powered system. To highlight a few, consistent performance. So no matter how many loudspeakers you have in a space, no matter how far these loudspeakers are, of course, within restrictions, how far they are in terms of how long the cables are, and all these factors get out of the picture. So you get the same performance no matter where your loudspeaker is located. Better frequency response, better bandwidth, better SPL, and no amplifier racks. That's a really important factor, because real estate, as we know, is getting more and more valuable, and you don't want to waste valuable real estate for rack rooms. And then when you build a rack room, you need to provide HVAC system for that rack room. You need to cool it down. You need to provide ventilation, and all those things. Another important thing is being a low power system, a 48-volt system. It is not mandatory to put them in a conduit for safety reasons. So that brings down a lot of cabling costs and cabling hassles that come with conduiting cables. And of course, these systems are safe without conduiting. So how do we do it? What's special about these intelligent DC products? Well, the drivers and electronics, we are known for it. We build high quality components, we build high quality loudspeakers, and we put the exact same quality control and the same design into intelligent DC products. So nothing changes. We have a standard 48 volts power supply. And there's something smart happening inside the loudspeakers. They're actually able to store some amount of DC power for those peak demands, which is how we're able to do high SPL. We're able to do those low frequency transients. It comes from this storing of power. This is just an example of a system that went from being a passive constant voltage system to intelligent DC system. As you see, the rack is pretty much just all blank plates now. If we go closer, we can see that there are 3 MPS power supplies, the ones with the blue looking lights on them now. And with this, we're able to provide 24 lines of power and signal distribution. So an overview of the system. This is how a typical intelligent DC system would be wired, and we're going to break this down and look at it component by component. Starting at the input, we have a Galaxy processor, which is providing audio signal to the MPS 488HP. And out of the MPS 488HP, we have a composite cable, which is a 5-core cable that carries both audio and power to loudspeakers. This is the pinout. This information is again available in the user manual, but it's just here for reference. And we don't always have to use the composite cable. There are customers who prefer using separate cables for signal and power. Yes, you can do that as well. The pinout obviously stays the same. We also have the option of having RMS, which is our remote monitoring solution, for which you will need an RM server. We'll look at that, and you can monitor your whole system using that. This is to just give you an idea of the kind of cable lengths that we are able to achieve. It is very impressive, considering that these are actually self-powered systems, and we are remotely powering them. And what I'd like to point out here is that these lengths are based on DC power drop that will result in not more than 1 dB loss in peak output. So this is the kind of precision we at Meyer Sound believe in. This is the kind of consistency we believe in delivering, where 1 dB is 1 dB too much. Again, these cable lengths and gauge information is available in the user manuals, etc. Jumping on to the product line. We have products to cover all gamuts, all applications. As you will see, it's a very versatile system, and we will also talk about why. We'll go through them one at a time. Starting with the power supply, which is the heart of the system. We have 2 power supply models. We have the 482, which is a 2-channel power supply, so it can do 2 input, 2 out. And we have the 8-channel power supply, which is the 488HP. They come in a few variants. Taking a closer look at the 482, in the front you will see LEDs. We'll talk about that. In the back we have 2 inputs, 2 outputs, or we can even link, making it a 1 in, 2 out, which is nice when you have, which is a nice option to have for distributed systems. Looking at the MPS 488, we have the same LED panel again, but now we have 2 different kinds of connectors. We have the EN3, which is a more secure connector. And we have the Phoenix, which is easily field terminated. You can easily terminate this connector in the field, so you can choose whichever you prefer for your project. Now, if you will see, I've highlighted the RMS optional card, which is in the Phoenix version right now, but you can get this card in the EN3 version as well. And if you don't have RMS, it's just going to be a blank plate, like you see the one in the EN3 version. Moving on to the input section, as we can see, there's 8 inputs. If we take a closer look, there's something very clever here. There are link switches that can link inputs. So, for example, if you want to run one line to power all 8 loudspeakers, you don't have to create Y cables or do anything of that sort. All you have to do is flip switches, and you can get a 1 in, 8 out device. The LEDs, very interesting. They've been designed and engineered to be as useful as possible. Apart from telling you whether the system is on or not, they can do a few other things, which is nice. When you are monitoring the system, you want to just take a look at the rack and see what's happening. You can start your troubleshooting from just the LEDs, even if you don't have immediate access to RMS. RMS, of course, will be an added benefit because you don't have to go and take a look at the rack. You can monitor the system from anywhere. Again, this LED state information is available in the user manual. Coming to point source, you will see we have a bunch of options starting from the 4-inch, which is the smallest of the family, to the 10-inch UPJ 1XP. Again, the idea here is to have different power output levels and different dispersions for loudspeakers, so you can pick one depending on your application. Seating speakers, we have a 5-inch and an 8-inch version, pretty self-explanatory, 5C and 8C. We have subwoofers that can take care of low-end reinforcement. Again, these are powered off the same power supply, so you're not running AC cables, which is nice for projects where running high voltage cables is difficult or is not an option. Cinema is very important for the IntelligentDC family because as people who are familiar with cinema, exhibition cinema room designs are aware that you are not allowed to run high voltage cables inside the exhibition cinema audience areas for safety reasons, for fire safety reasons. With the HMS family, you can run these loudspeakers and the cabling without any issues because they are low powered. I've highlighted the HMS 15 here just to point out that this is a loudspeaker that would require 2 runs of power from the MPS to meet its demands. The MM10, the subwoofer that we saw earlier, the 10-inch, comes in a special version where you have a power supply built in. As you will see, you have 2 outputs here that are commonly used to power the MM4 XP and UP4 Slim, so you don't even need a power supply if you have a small system with a sub and a satellite speaker, if I may. You can use the same composite cable to make it a neat setup for a small portable system or a small conference room kind of an environment. Looking at the remote monitoring, this is where IntelligentDC gets its added value from. We are able to monitor the complete system. Each output of MPS 488s, which are the ones that come with the RMS option. We can monitor up to 50 individual loudspeakers using 1 RM server or 96 IntelligentDC loudspeakers. You can connect up to 12 MPS 488s to 1 RM server. You can, of course, have multiple RM servers on a network. There are relay outputs and opto inputs at the back. We will take a look at that. They can hop onto your existing Ethernet network to have communication with your local computer. You can even give it internet access and set up triggers for email notifications, so you don't have to constantly keep looking at it. The triggers will make sure that email reaches whoever it's supposed to get to. This is how RMS will look inside Compass when you open and get to it. This is, of course, a mixed system just to show you the possibilities. We are going to focus on this one that I've highlighted in red. This is how an MPS 488 HP would show up with its 8 individual channels. We'll take a closer look at that a little later. This is the back, the logic I/O. This is the back of the RM server. The green connectors are for logic I/O, for relays and things like that. This lets you interface with external systems for fire alarm muting and overrides as such. So it is an important feature for systems that require safety features to be built in. So yeah, this is how you can get your mute alarm overrides and all for your whole system, depending on how you configure it, of course. Just to give you an idea of how the RMS would RM server would fit into your system. This is how it would look. You can have, like I said, more than 1 RM server if you have as many loudspeakers. Taking a closer look at the window that we saw earlier, we're able to see 8 individual outputs of the MPS, which is very nice, and you can mute them and unmute them remotely from here. You can select speaker type. You can give them custom labels like surround 1, 2, 3, 4, 5. These are custom labels, and you can label them as you wish. We can identify MPS 488s in both directions. So you can identify, you can do a wink from here and it'll flash on the device, or you can click a wink button on the device and it'll flash here. So it's easy to troubleshoot large systems. We are able to monitor state, input signal, idle current, peak voltage, mute and solo, of course. Coming now to case studies. You would have seen pictures that look like stock images probably through the other slides. These are actual installs and applications of IntelligentDC systems. What you see on the left is a cafe, and on the right you see a lounge. We have an art gallery in Amsterdam on the left on this slide, and we have what looks like a very high-end cinema post-production mix down facility. Now, I said earlier that our speakers are very versatile because they're built as loudspeakers, and they do exactly that. That is, they reproduce, the goal is to reproduce audio without artifacts. We don't build loudspeakers saying this loudspeaker can go only for distributed audio, this loudspeaker can go only in cinema mixing environment, and this high-end loudspeaker can go here. We build loudspeakers that reproduce whatever you put into them to their best ability, and all you have to do is pick a model based on power. Merlin recently did a webinar on power scaling. That is something I would urge you to check out, because that would apply again here on how to select speakers and how to scale power. So you pick a loudspeaker based on your power requirement, and you pick a loudspeaker based on the second factor, which is dispersion. So do you need a wide dispersion, a narrow dispersion? How far are you throwing it from? So that's all that you need to pick. It is very easy to go through this once, because there's only one lineup of products inside IntelligentDC that can do a certain power and a certain dispersion. Again, more applications. As you see, there's a bar, and the picture in the middle is IntelligentDC system, an MM4 XP actually, used as a fill system for a much larger system inside an auditorium. An airport for the PA as well on the right. Moving on to our first case study, Dubai Mall. Yes, it's a huge mall. To give you a sense of scale, this is a screenshot taken from maps. This is the Burj Khalifa, which is about 830 meters. It is 830 meters tall, which is right next to Dubai Mall, which is this area. This is the core area of the mall. Of course, there's more extensions for parking and other things, but I just marked out the core area. And what you see here on your top, where my mouse pointer is now, the smaller section, which is across the road, is actually a new part of the mall. I think it's just a few months old, if I remember it correctly. This has more outlets and, of course, more parking. Here we have installed. This is a complete Ashby 8C installation. And if you park your car here across the road and have to walk down to the fountains, where you have a beautiful light and video show with video on the Burj, this is again a Meyer sound install, you will be walking a little over a kilometer after parking your car to get to the fountains. And if you start walking at this end of the mall, which is close to Burj Khalifa, and try to walk across, that's again a little over a kilometer. Just to give you an idea of scale of this project, coming to requirements, what they needed was a system that was visually and sonically invisible. What I mean by that is, of course, nobody wants to see loudspeakers from an ID interior design point of view, and they wanted a seamless coverage where you as you walk, you don't really spot loudspeakers, but you have this seamless flow between coverage areas of the loudspeakers. They required high fidelity audio. Of course, this is a premium property, and audio is an important part of the experience as you walk in here. They play some really nice music. Speech intelligibility is important. Because they do make some announcements sometimes on the system, and the call to prayer, which is what happens 5 times a day in this part of the world. Everything comes to a standstill, and a call to prayer happens, which is a speech-based track, letting people know that the prayer has started. This is important to them. Scalability was important for this project. This is something they wanted from the start, because when you're building a project like this, you don't build it all at once. You build the main one and then you keep adding sections. Like we saw, the section came up across the road. They keep renovating, they keep changing. It is important to keep the space relevant. So scalability was a big factor. Reliability, of course, everybody wants their systems to be reliable. So if I have to list down the core applications here, it is background music, it is announcements, and the most important, call to prayer. What did we deliver? Well, this mall has over 950 intelligent DC loudspeakers. We have different models, of course, starting from the MM4 XP, the ASHP 8Cs, UP4 XP. These have been color matched so that they are invisible, as you would have noticed in the pictures before and now. These are all white, but there are a few surfaces that are not white, and the loudspeakers were color matched. This is done at the factory if you request so. Seamless scaling over a decade. This mall is a little over a decade now, and they've been adding sections and renovating sections, and we've been adding loudspeakers there, and they've been getting exact same consistent performance in the old spaces and new spaces, because these are self-powered systems and everything is built in, and the loudspeaker sounds exactly the way it sounds when it left the factory 10 years ago, or whether you bought a new one that left the factory last week. There are well over 100 MPS power supplies, and the system has been extremely reliable. As you can see that they haven't changed, they haven't felt the need to change loudspeakers in this space over the past more than a decade now. They're extremely happy. About the call to prayer, this is a very important part of any public space in this region. The call to prayer has to be clear, has to be soothing. It cannot be a loud, harsh announcement. Neither can it be a muffled prayer. And they've actually been very happy with the performance, and a lot of malls in this city, as you know, there are a lot of large malls, have tried to replicate this call to prayer. When I was having a chat with one of the guys there, they said that a lot of malls approached them and tried to replicate by playing the same audio track, but then they soon realized that it's just not the quality of audio recording and the audio track, but it's also the system that provides the intelligibility that they get inside this mall. The next project is Mer, which is again a large project. This is spread over 2.5 kilometers. It's a mix of retail and F&B outlets, along with a beautiful beachfront. The requirements here were high SPL. It was background music, but then you can't call it background music because it is loud. It's foreground music because it's outdoor. You have environmental noise, and the SPLs that were needed were higher than a typical background music system. Speech intelligibility, again, was important because they make announcements. Scalability, like I said, large projects, they don't build overnight. They do keep expanding and renovating, and they wanted to maintain the same performance. Weather protected, this is why I brought this project up. We will talk about that. And of course, everybody needs a reliable system. So the core application here is foreground music and speech. What did we deliver? Well, there are over 300 intelligent DC loudspeakers here, driven by over 40 MPS 488 HP power supplies. We have a mix. We have UP4 XPs and MM10 XP for the low end, and these are weather protected. We do make all intelligent DC products in a weather protected version where you can leave them outdoors and they will be fine. Just to show you an example, this is a loudspeaker. Yes, it was black when it left the factory, but saline water spray from the beach. We have sandstorms here. We have heat. I don't have to tell you about temperatures in the desert here. We have exposure to sun, so UV becomes a big factor because you are exposed to direct sunlight that many hours a day. And rain. Yes, it does rain in Dubai, and these speakers have seen all that. As you can tell, they're quite brown now, but they still work. They still perform exactly how they used to perform 2 years ago when we installed them. This is another picture just to show you how open these speakers are and how unprotected they are. These two red rectangles are pointing out to UP4 XPs that are mounted there. And yes, they've also been quite happy, and they've been quite happy with the system. The subs are also exposed outside, and they've been working perfectly fine. The next project is a very interesting project. The National Museum of Qatar. It's an immersive AV experience inside a museum. These disc-like structures make this building a very beautiful sight to look at. There are 539 of these discs, and these discs are not just on the outside. They absolutely go inside the building, which makes this design a very interesting design. Even as AV designers try to work their way around the discs inside. This is I think about 8,000 square meters of floor space inside, so it's quite big. This is how it looks like inside. As you can see, the walls and ceilings and all, they come at different angles at different places. We will talk about that. High fidelity audio was a requirement here. Again, high intelligibility, these are pretty much standard across all projects. The factors that stood out here for this project were that it needed to be time aligned because it was a 3D immersive experience inside. The system needed to be concealed. As you can see, they've used every possible surface for video projection. So mounting speakers on the wall was not an option. Mounting speakers on the ceiling, in some cases worked out, in some cases didn't, because of the orientation of the ceiling and because of how much space of the ceiling was used for projectors, as you can see in this image. They needed a comprehensive control of the system, so they needed control over each and every loudspeaker individually. Everybody needs a reliable system. They needed one too. It is an important museum for the country. And they needed remote monitoring. Of course, for a project like this, you want remote monitoring. The core application here is immersive audio, three-dimensional audio. So what did we put in? As you will see, unlike the other projects, we have a big mix of products here. We have seating speakers, we have the UPM 1 XPs and UPM 2 XPs. That's again for different kinds of dispersion. We have the then very new UP4 Slims, UP4 XPs. For the low end, we had UMS 1 XPs. So these were over 280 loudspeakers with over 40 MPS 488 HP power supplies driving them. In this venue, we used a Dimitri system for control of control and processing for each loudspeaker. This is for the immersive audio system. And we deployed our server for remote monitoring, which was very important to them. We delivered high SPL, high quality audio that we are known for. The most important thing here for this project was, even though we used a varied range of loudspeakers, they were very easily able to match them for voicing, because when you're doing immersive audio, you want seamless transition between loudspeakers. You don't want the object to sound different as it moves from loudspeaker to loudspeaker. And in the same space, we had a mix of loudspeakers because of the way the interior of this place is designed. So if you had to pan sound, maybe you're moving from a loudspeaker in the ceiling to a loudspeaker pretty much on the floor to a loudspeaker somewhere else. And matching voicing for this was very important. Again, emphasizing the fact that having control over loudspeaker voicing and having control over phase and having control over frequency response and consistent performance is really important for immersive audio. Immersive audio is the future. It's been around for a while. We've been doing it for a while, but IntelligentDC becomes that much more relevant with immersive audio taking the hot seat now. Again, time aligning the system was important. We needed to control each individual loudspeaker separately. This becomes, like I said, impossible when you have a constant voltage system that is driving more than one loudspeaker on an amplifier line. All the parties in this project are extremely happy with what the outcome was. This is a quote from Frederick, who was the on-site project manager from EDA and Klang, who was spearheading the audio and the audio experience for this place. They did try a lot of different loudspeakers. UP4 Slim at that time was pretty new, and they tried it and were absolutely blown away. And that's how the UP4 Slims got quite a bit of presence inside this museum because of the small footprint and the kind of audio that they were able to deliver. This is a quote from the sound designer. the lead consultant at EDN Klang, and he again was very happy with how seamless everything was when they had to pan things, and how easy it was to match, to how they didn't have to worry about voicing every system differently, because we were pretty much just delivering whatever was coming into the speaker was what is coming out of the speaker, which is your ideal case scenario, especially when you're trying to design and deploy immersive audio with the number of loudspeakers that we're talking about in this case. Yes, so if you are in Doha, Qatar, please do visit this museum. It is a beautiful experience, especially with these with the video projection and the way the sound design has been done. The next one is not as glamorous as all the others, but nonetheless that much more important, because these are the kind of spaces that all the big and important decisions are made. This particular room is a boardroom that belongs to Capgemini in India. This was done by our partner O2K in India. Office 2000 is what they're called. This is a 21-meter long room. As you can see, there is a partition midway, so the room can become 2 rooms if the need be. So why is this project relevant? Well, they needed speech intelligibility, of course, because it is a boardroom. They needed control dispersion. We will talk about that. They needed the speakers to be invisible because it is a corporate space. You don't want loudspeakers hanging out here and there. They needed to time align the system because they use a very clever system for propagating voice through the room. We will talk about that. And they, of course, needed a reliable system because you cannot have systems in such rooms where such important meetings are taking place to fail at any point. So yeah, the core function here was AV conferencing, which is they are interacting with their colleagues all over the world in similar boardrooms, and local voice propagation, because it is a big room. At 21 meters, you will be struggling to be heard from across the room. What did we deliver? Well, we have MM4 XPs in the ceiling. If you look carefully, you will spot them. They're extremely small and black. We couldn't, there was no scope for putting ceiling speakers in here because of the way the ceiling was built, and they needed a tight dispersion. So MM4 XP was the way to go. There are 2 MPS power supplies, one for each side of the room. So even if you shut it off, they still work independently. These loudspeakers are low distortion. Again, the same distortion coming from referring back to constant voltage systems, where transformer saturation starts kicking in, especially when you have voice coming in, very modulated voice. We delivered a system with low distortion and very high intelligibility. In boardrooms such as these, it helps you minimize fatigue because when you are listening to a distorted system for a long time, you tend to wear yourself out because you need to focus that much more to keep track of what's happening and who's saying what, especially when you cannot see the person all the time. And these systems, IntelligentDC systems, help with that because they just sound good. And the control dispersion, like I said earlier, was important because what you see in the room, the white tiles are actually their microphones. They use seating area microphones. And you would notice that a talker is equidistant from the loudspeaker and the mic, which makes things difficult when you're trying to get good gain before feedback. And in this case, they are extremely happy with the MM4 XPs because of the tight dispersion pattern that it has. So all the frequencies are very well controlled, and they were able to get really good gain before feedback, even though the microphones were equidistant as the same distance as the loudspeakers. And this is of course important because for clear audio transmission, you need good gain. For good audio pickup, you need good gain before feedback. Time aligning for propagation, they use a very clever system where if I'll quickly explain, in a traditional PA system, if you are sitting at one end of the room and you're trying to talk to someone at the other end of the room, without a PA, you just have to shout the good old way. If you have a traditional PA system, when you speak, the sound is going to immediately come out of the loudspeaker on the other side. But the sound that travels through air is going to take a little longer to reach that person. So there's going to be a little bit of a clash between the acoustic energy reaching the person and the sound from the loudspeaker reaching the person a little earlier. What they did here is they have taken control over each individual loudspeaker output separately and programmed it in a way where sound would travel from speaker to speaker depending on where the talker is. It would come out of the speaker at a delayed time, arrive roughly at the same time as the acoustic sound from that person would reach wherever the speaker sound is coming out of. And for this time aligning, and gaining control over each loudspeaker output was important. And this, of course, could not have been done if this were a distributed system on a constant voltage line. So that is a quick look into 4 different projects and how things were done at these projects, and how IntelligentDC was able to change the way things were done at all of these projects. Moving on, designing in MAPP XT. Before I move on, this image is again from the National Museum of Qatar. As you see, putting ceiling speakers here would not have been fun. So yeah, seating surfaces kept changing. That was a side note. Moving on, I would like to talk about setting design goals for such distributed systems. I look at the points we have on screen as a checklist. One is to a checklist before you start designing to set your goals for a design. One is to find out the application. Application is what you're using the system for. As you would have noticed, every project that all of the 4 projects that we just saw, there was a very clear application for each of these systems, because that helps you define what kind of system design you're going to approach. Getting target SPLs is nice, is important. You can't always get it. Sometimes you will have to ballpark by looking at other information that we will go down in the list. One of the first ones I would look at, if I don't have a specific target SPL, is to find out what environment it is in. Is it a boardroom, which is extremely quiet, or is it a noisy lobby outside a hotel, or is it an outdoor beach property? So that would define how much, what kind of SPL targets we're looking at. You need to look at rack room locations, because that will also help you decide how you're going to approach a bird's eye view of the system, and in terms of feasibility, whether you're able to run these cables to these distant locations without degradation in audio. Mounting feasibility, again, this is important because you need to know, like in the museum, in the National Museum of Qatar, mounting them was not straightforward. We had to look at it location by location and decide whether you're going to use a U-bracket, whether you're going to mount it on the wall, whether we're going to put it in the ceiling. So mounting feasibility is something we should check. Automation interface for such projects becomes very, very, very important, because most of these projects, they're not expecting technicians to go and power on and power off systems manually. They're looking at doing it through a BMS system or such. And in our case, we can do it via the Galaxy, which is why you see the picture of Galaxy processors on your screen right now. We can do it via Galaxy, which can receive OSC commands over TCP/IP or UDP, and we can also do, as we saw, we can do a little bit of control with using RM servers. Safety features, it is important to check what kind of safety features they're looking for, whether all they want is mute overrides, or they want to override sources, or all those kind of factors need to be considered. And monitoring becomes important when you're talking about large distributed systems, because you possibly cannot really walk around every day and try and figure out if everything is working inside the space. So remote monitoring becomes very, very important. And the Galaxy now, a recent announcement, actually, we have SpaceMap Go, which will work off Galaxy processors, which is very exciting for us as well. This is moving towards more immersive audio. And as you saw with the National Museum of Qatar, when we have loudspeakers such as the IntelligentDC loudspeakers, which have small footprint and can be everywhere for immersive audio, bringing the Galaxy into those kind of scenarios becomes very interesting proposition. moving on, here's a quick way to check ceiling speaker coverage. This is just a quick workflow tip that I wanted to show you. Let's take the example of an Ashby. I will try and explain. Let's take the example of an Ashby, which is a 100-degree dispersion. What we have a few factors that you need to consider here. One is the height of the speaker itself, which is the height of your ceiling, which is from the floor to the ceiling. And the second height that you need to consider is the height to the ear. So what we're looking at is the distance from the loudspeaker to the ear, which is our height in this case. And what we need to find out is speaker spacing. So if you have one speaker here, where do you need to put the next loudspeaker to get that even coverage that we saw at the beginning of today's session when I showed you that MAPP XT clip? So to do that, we need to look at lateral aspect ratio, which for 100 degrees is about 1.53. It's rounded off to 1.5 here. So you take this height, for example, if this height is 1 meter, the loudspeaker spacing is 1.5 meter. It's as simple as that. So every 1.5 meters, you're going to need a loudspeaker to get that even coverage at ear height. It is important to consider ear height and not the height from the loudspeaker to the ground. Just to help you correlate that information with a familiar environment, this is a prediction in MAPP XT. So you have your loudspeaker. Your height is from the loudspeaker down to the ear level or the listening height. This could be seated audience, this could be standing audience. This is something you need to, this is information you need to have beforehand. And then you just multiply that by the lateral aspect ratio. For 100 it is 1.53, and if you have an 80-degree loudspeaker, you have a lateral aspect ratio of 1.28, which means you're going to need more loudspeakers to cover the same space. Which brings me to the point that most loudspeakers that we make in the IntelligentDC family, and there are a lot of loudspeakers that we make which are wide dispersion. We make high SPL, we make loudspeakers that are able to deliver high SPL. So we also have now made that, we also have them in a wide version, 100-degree version and 110-degree version in some of the other loudspeakers. And this helps you bring down the number of loudspeakers that you would need to cover the same area. This is again helping with bringing down the cost of ownership of a system, where you are able to cover the same area with fewer loudspeakers, which is always a nice thing. So how do we get to this? Let me quickly pull up MAPP. Let's take an example. We already have an Ashby HC here, which is great. In order to find out where the next Ashby HC is going to be, we need to figure out what the height is, from what the distance is from the loudspeaker to the listening plane. So I've set in a listening plane here, which is 1.2 meters, as you will see my mouse pointer point out in the y-axis. This is 1.2 meters. In MAPP, if you quickly want to check height without too much trouble, what you can do is draw a line from in this case the loudspeaker to the listening plane, and select that, and let's right click the properties. As you will see here, it is roughly I closed that. This is roughly 2.2 meters. So if we do the math that we saw on the last slide, 2.2 meters into 1.53 is going to give you 3.37. So what I do to quickly space these speakers in, especially when you're doing larger designs, it can become a daunting task. But here's a quick trick. You just draw a line from the center line of the loudspeaker, and you can edit this line. You don't have to draw it at the precise length, and we can change the length of the line here. If you go in, by default, you will see you will see the Cartesian coordinates selected. You just move that over to polar, and you can specify the length of the line, which we calculated to be 3.37, rounding it off to 3.37, and apply. So that is now the loudspeaker spacing. What I can do is select my first Ashby, copy that, and I can, using Command C, and I can go Command V or Control V on Windows, and I can just place it at the edge of this. This will get us into a good ballpark placement of these loudspeakers. Now, to copy these on next, I can just select the loudspeaker, select the line, copy them together. Again, Command C and Command V. As you see, it's copying with the line. So now I can quickly go and place them like that. And it becomes that much easier to quickly place the loudspeakers at the even spacing that you need to do. And there you go. So according to this, I need 6 loudspeakers to cover this space. You can also select all the loudspeakers together and roughly center them. You can, of course, fine tune them and spend more time, get into the smaller details. But I'm trying to show you the quick and dirty way to get pretty close to what you would do in the final design. Now, this is pretty much centered, so I'm going to leave it as it is, or we could have just selected and moved all 6 speakers around. In this case, I just selected 5. And if I go to 4K, 1 octave, and predict, you will see that we have a pretty even coverage across the audience line here, which is within a 3 dB variance, which is great. So this is for the length of the room. This is a 20-meter long room, and we used 6 Ashbys along the length of the room. But we also need to see the width of the room to know how many of these rows we're going to need. So for that, what we can do is use a transection view, which is a section view of the room along the width. So this room is about 7 meters wide. Again, we already have one Ashby here, and the loudspeaker spacing doesn't change. It is the same spacing because you have the same distance from the loudspeaker to the listener. So we have the same 3.37. I'm going to do the same thing and draw another line here as 3.37. Select that. I can edit and specify a particular length that I need, 3.37. You can, of course, do this manually, but this would be nice when you're doing larger projects and you need to copy things over. And there you go. So it looks like we just need a row of 2. So if I look at the section view, we're looking at 6 loudspeakers along the length and 2 loudspeakers along the width. So that's 6 times 2, 12 loudspeakers to cover this space. If I predict these 2 loudspeakers, you will see that we have the same coverage within plus or minus, or within a variance of about 6 dB, I'd say. And that is how you can quickly get to these kind of designs for distributed audio without too much trouble. Just remember the lateral aspect ratio, find out the corresponding number, multiply that by the distance between the loudspeaker and the listener. And that is about the end of my presentation for today. And I will be, thank you all for your time. And
that's great, Rahul. Much appreciated. I think I have something for you. Let's see. What do I have for you? I have this for you. Do you see my video?
Oh.
Well done, sir.
Yes.
Well done.
Thank you. Thank you so much. Thank you. If there are any questions that are relevant to today's topic, I'm happy to take them. Thank you, Merlin. That was a nice video applause there.
Well, you deserve it. Okay, so that's awesome. Let's look at the chat. If anyone wants to ask a question to Rahul, we still have a couple of minutes left. Please make use of the raise hand feature, and then Rahul and I will try to answer the question to the best of your ability. Now, Rahul, you might have noticed that during your narrative, somebody was inquiring about the playback through Dimitri, and I proposed that might better live in its own webinar.
Yes, I can see that now. The Dimitri is actually a very capable machine. What we did with it at National Museum of Qatar is only scratching the surface of that system. And like Merlin said, that is a webinar in itself or two.
Okay, and then we have another question from Rich Highland. Why can't you time align a 70-volt system?
Okay, so what is time aligning? Time aligning is trying to get to, let's take a simple example of 2 sources, and both sources facing the same direction. You have source number 1, which fired and reaches your listener, and you have source number 2, which fired and reached your listener. Now, these 2 are going to reach the listener at 2 different times. The one closer is going to reach sooner, the one further away is going to reach later. And in order to to make them both reach at the same time, we're going to add a delay to the one that is closer and push it back. Now, when you're on a 70 volt line system, and you typically have all your loudspeakers in a zone or in a line on one amplifier. And if I change the time of the input that's going into that amplifier, it's going to change the time for all the loudspeakers. So that kind of makes it impossible to tune them. Of course, you can have multiple amplifiers driving different loudspeakers and then time align them, but that would be a waste of resource, because you most probably you don't want to drive one loudspeaker from one constant voltage system amplifier.
Just so you can time align it.
Yeah, just so you can time align it.
Excellent. Okay. Any other questions at this point? If I am right, the black spots IntelligentDC speakers. Where are the speakers close to each other in Qatar Museum? I struggle with the interpretation of that question.
Yes, I get the question. I understand it because I know that image well. This is a question from Tanmay. Not all the black spots that you see in the ceiling. Let me pull that up again. Let me see if I've got the right image for you, Tanmay. This. I think you are referring to this or a similar picture. Not all these are. Not all these black spots are.
Rahul?
Oh yeah, yes. Thank you for pointing that out.
That's fine.
Grab my screen, and are you able to see it now?
Yeah, we can see your screen.
Okay, so not all these black spots are loudspeakers, if that's what you meant. Some of these are other things. Not all of them are loudspeakers. I think that should answer your question, Tanmay. Some of them are other things that are in the ceiling and that need line of sight or access into the audience area. That should answer your question.
Excellent. Well, from what I can tell, the chat appears to be cooling down, which means thanks you, Rahul, once more. Rahul Samuel, technical support specialist. Much appreciated. Please allow me to finish today's session with a couple of household notes with regard to upcoming webinars. So of course today's recording will be uploaded to the YouTube channel, as we're about to see in a while. This Friday, we will have John Manito join us as guest lecturer, and he will talk more from a global perspective about IntelligentDC. We have seen several examples today, but that is just scratching the surface because it's a very versatile product range. So John Manito will join us on Friday, May 1st, and talk about a much broader perspective of the application and implementation of IntelligentDC. I would also like to remind you that not this Friday, but the Friday after that, so Friday next week, May 8th, we have our second on-demand a la carte webinar. And last time we did power scaling, and this time we added another option to the menu, which is for you to choose from, which is Montreux Jazz, M-Noise, or Roskilde Festival. If you want to make your vote known, please go to the Meyer Sound Facebook group called the Meyer Sound User Community. At the top in the announcements, you will find the survey where you can make your preference known, and then in little over a week from now, we will be happy to discuss whatever you end up choosing. As I said before, today's webinar by Rahul will be uploaded to the YouTube Thinking Sound channel, so you can expect to find it there later today. And that brings us to the end of another webinar. Thank you for being here. Again, a big round of applause to Rahul for sharing his vast knowledge about IntelligentDC with us. Much appreciated. And that means that we're at the end. Thank you for being here, and hope to see you next Friday. Now, for those that speak Spanish, tomorrow our Mexican colleague Guatemoc Mendez is going to talk about IntelligentDC. in that corner of the world, which will certainly feature different examples. So very much looking forward to his presentation as well. Okay, stay safe, stay healthy, everybody, and see you next time.